As you know that I am doing material science previous year questions. This is directly from the exams like GATE, IES and IAS. So I have already completed many lectures. So if you are new in this channel, please watch this material science playlist so that you will get lot of question at one place. Anyway, this is about myself. Let's see today's questions. Okay, so this question came from GATE 2003. Let's read that. During the heat treatment of steel, the hardness of various structure in increasing order is. Okay. So martensite, fine perlite, coarse perlite, spheroidizing. Okay, so they are asking the sequence actually. Okay, fine perlite, coarse perlite, spheroidite, martensite, and whatever it is. Okay, so this they are shuffling in the options. We'll see what is the answer. It is actually during heat treatment, the hardness of various structures in increasing order. Okay, so the hardness of various structure in increasing order. So you remember one thing, the hardest form is the martensite. Okay, so you can eliminate two options from here very easily, is like option number A and option number C, because here martensite is not given in the last. Okay, so but in B and D, martensite is given in the last. So out of these two, any one can be the answer. Okay, so anyway the answer is actually D. First is spheroids, coarse perlite, fine perlite and martensite. So this is the correct sequence of hardness. Next question on case hardening. In case carbonizing carbon is introduced to form a high carbon layer at the surface. The carbon is introduced in the form of graphite flake, perlite, cementite, free carbon. Okay, so in actually you will get free carbon. Okay. So like carbon introduced in the form of free carbon. I'm sorry. Next again it is like match list, name of treatment, media used. Okay, so pack carburizing, gas carburizing, cyaniding, nitriding. Okay, so ammonia gas, sodium cyanide, carbonized compound, ethane. Okay, so we have to match with these. That see, the pack carburizing is nothing but is carburizing compound. Gas carburizing, it is ethane. Cyaniding, it is sodium cyanide, and nitriding, so it is ammonia. Sorry. Okay, so this is the match list, so answer is A. Next question, introduction, sorry, not introduction, induction hardening is basically a carburizing process, surface hardening process, core hardening process, none of the above. Okay, so induction hardening is basically induction is basically surface hardening process. Okay, so the answer is B. Induction hardening is basically a surface hardening process. Next, guideway of Leith bed are hardened by, okay, carburizing, cyaniding, nitriding, flame hardening. So these are the four options. You'll see that. So the guideway of Leith bed are hardened by flame hardening. So the answer is D. Next question, carbonized machine component have high endurance limit because carbonization raises the yield point of the material, produced a better surface finish, introduce a comprehensive layer on the surface, suppresses any stress concentration produced in the component. Okay, so carbonized component have high endurance limit because it is actually introduced a compressive layer on the surface. Okay, so the answer is C. Next, heat treatment to non-ferrous alloy. So let's read the question. Which one of the following elements alloy exhibit season cracking? Okay, iron, brass, aluminium, steel. Remember, they are asking for non-ferrous alloy. Okay? So it will be actually B, brass. Okay, so the copper alloy sometimes also known as brass, copper alloy cracks in anomical solution, season cracking. Okay, stainless steel and aluminium crack in the presence of chloride, steel crack in the presence of alkali. Okay, boiler cracking or caustic cracking. So please remember its answer is B, brass. Next question, which one among the following is most effective strengthening mechanism of non-ferrous metal? Okay, solid solution hardening, stain hardening, grain size refinement, precipitation hardening. Okay, so strengthening mechanism they are talking about for non-ferrous. So this is actually D, precipitation hardening. Okay, so the precipitation hardening helps more in the strengthening mechanism for the non-ferrous metals. So the answer is D. Next, which one of the following pair is correctly matched? Okay, so here we have to correctly match whatever is given. Solid solution is strengthening, increasing density of dislocation, dispersion hardening, creating strained region in the crystal, stain hardening, creating particles to resist the movement of dislocations, precipitation hardening, creating particles by decreasing solubility of one phase in another. So this is actually D is correct. Okay, so and rest is wrong. Okay, rest is wrong. So precipitation hardening, creating particles by decreasing solubility of one phase in another. Okay, so this is the correctly matched, rest is wrong. Next assertion is carburizing is done on non-ferrous alloy to increase the surface hardness. Okay, precipitation hardening of non-ferrous alloy involve solution heat treatment followed by precipitation heat treatment. We'll see that. See, carburizing is done on non-ferrous alloy to increase the surface hardness. No, this is wrong. This is wrong. Okay, next, precipitation hardening of non-ferrous alloy involves solution heat treatment. Yes, followed by precipitation heat treatment. Yes, both is correct. Both means not A and R. The statement is given like solution heat treatment, yes, and the precipitation heat treatment, yes. So that's why the answer is D. Assertion is wrong and reason is correct. Next question is again what is it? Assertion is a question. Carburizing is done on non-ferrous alloy to increase the surface hardness. We have seen that this is actually wrong. The precipitation hardening of non-ferrous alloy involves solution heat treatment followed by precipitation heat treatment. See, the same question they have repeated. Okay, so this is actually wrong and this is correct. Answer is D. Okay, the answer is D. This is wrong and this is correct. The same question they have repeated twice. Okay, so this was the end of a few more questions from the previous year question of material science. I will come up with the more question, and I will try to finish this previous year lecture series of material science as soon as possible. Okay, thank you for watching. Bye bye.